Mixed Up Nuts, a company which produces mixed nuts, receives a shipment of 1,600 ounces of walnuts and 3,600 ounces of almonds every day. The manager, Larry, decides he wants to try a new mixture consisting of only walnuts and almonds. He makes a lower-priced version consisting of 10 ounces of walnuts and 6 ounces of almonds, and a quality version consisting of 4 ounces of walnuts and 12 ounces of almonds. If Larry decides to sell the low-priced version for $2 and the quality version for $3, then we need to find out how much of each should be made daily to maximize the profit. So this is going to be a linear programming problem. We're going to create a system of inequalities to maximize the profit for this company. And the first thing we need to do is assign variables to values. But if you read on in the next sentence, that's already been done for us. It tells us that X stands for the amount of the lower priced mixture, and Y stands for the amount of the quality mixture. Now we need to start writing inequalities to make a system that we can use to maximize the profit for this company. So let's start with walnuts. We know that the lower priced version has 10 ounces of walnuts, and the quality version has 4 ounces of walnuts. But remember, the company only gets in 1,600 ounces of walnuts every day. So we could write an inequality saying 10x plus 4y has to be less than or equal to 1,600. For the almonds, there are 6 ounces in the lower priced mixture and 12 ounces in the quality mixture. But remember, they only get in 3,600 ounces every day. So we could write another inequality saying that 6x plus 12y has to be less than or equal to 3,600. We also know that there can't be a negative number of lower-priced mixtures or quality mixtures, so we could write 2 more inequalities saying that x has to be greater than or equal to 0, and y has to be greater than or equal to 0. Now that we have a system of inequalities, we have one more equation we need to write, and that's the equation for profit. We know that if the lower-priced version sells for $2 and the quality version sells for $3, then the total profit for this company is going to be 2 times x plus 3 times y. The next step is to graph all 4 of these inequalities on the same plane but as equations. So instead of having the less than or equal to signs and the greater than or equal to signs, we're just going to change these all to equal signs. But before we graph, we need to change these first 2 equations so that they're solved for y, and I've actually already done that for you, so let me show you those equations. The first is y equals negative 5/2 x plus 400, and the second is y equals negative 1/2 x plus 300. So now we're going to graph these 2 equations, and x equals 0 and y equals 0, all on the same plane, and then look at where the shading would be. Here's the graph of all the lines graphed together. We can see here the 2 lines that we solved for y, but remember they started out as less than or equal to inequalities, so that tells us that there will be shading underneath both of these lines. So here's where the area would be underneath the first line, and here's where the area would be under the second line. So already we can tell that that overlaps in this area here. But remember, there were 2 more inequalities. X is greater than or equal to 0, and y is greater than or equal to 0. So that limits the area of shading to this area here. And now what we're going to do is find 3 points, this point, and this point, and we're going to use all 3 of those points in the profit equation and find out which one brings in the biggest profit. So we can identify this point as 0, 300, this point as 50, 275, and this point as 160, 0. So now we just need to substitute the x and y values into this equation. So for the first one, 0, 300, p will be equal to 2 times 0 plus 3 times 300, which is 900. For the second coordinate, 50, 275, p will be equal to 925. And for the last coordinate, 160, 0, p will be equal to 320. Looking at these 3 profit values, we can see that the second one is the greatest, 925. So in order to maximize the profit for this company, they need to sell 50 lower-priced mixtures and 275 quality mixtures. And that's the final answer to problem 15.